This video is for engineering students making their ejector pins and or sprue pullers for their injection molds. The ejector pins are used to force out the plastic product from the cavity on the behalf of the injection mold. A sprue puller is similar to an ejector pin, but with a Z-shaped slot cut into the pin to pull the sprue out of the sprue bushing, which is located in the A half of the injection mold.
This tutorial assumes you have already designed your injection mold and have determined the length of your ejector pins and sprue pullers. Before cutting, make a mark about 1/10 of an inch longer than your desired length. This will be your rough cut dimension.
When entering the lab, basic safety protocols should be followed, such as wearing safety glasses as approved by the engineering department, as well as a visible ID badge. When operating the chop saw, all extra tooling and material should be cleared from the surrounding area due to flying sparks created by the cutting operation.
This is the mark of our rough cut dimension. Line the mark up with the inside of the chop saw blade to account for the width of the blade itself. After setting the pin where you want it, clamp the vise to keep the pin from moving during cutting. When cutting the pin, bring the chop saw down with even continuous pressure until you cut all the way through the pin. Before removing the pin, wait until the saw blade completely stops spinning, and then unclamp the vise and remove the pin. Before you start machining, the first thing you want to do is prime the pump on the left side of the machine to pump hydraulic fluid into the table to allow for easy transitioning in the X, Y, and Z planes.
The used one's going to look like this, and after it's dressed, it's going to look like this. We're going to do that dressing with an industrial diamond that's mounted on a shank. And we'll clamp it in the same way we would clamp in an ejector pin. We'll verify that it's locked down tightly, and we'll bring it up to the work the same way that we would do a pin. Now, if you look at the circumference of this wheel, and you see where I'm touching it, you can see the direction of the forces. We would like these forces to go down against the magnet. We don't dress or grind on this side because it would be lifting our tools up off of the table. We dress and we work on this side. So we'll do this approximately the same way that we do a pin.
When operating the Taft Pierce grinder, the metal guard encasing the grinding wheel, visible from the front of the machine, should be fully lowered. This is the close position.
So after you've ground down your ejector pins to the rough cut dimension that we did earlier, you're going to take your V-block and set it on this magnetic plate. You're going to move this surface flush with the back edge here until you can't push it towards you any further. And then down here we have a keyhole with an off and on sweating, and this activates the magnetic plate that the V-block sits on. So we're going to use the Allen wrench, get in here, and turn it all the way to the right until our divot is pointing to on. And then wiggle this about, make sure it doesn't move, looks to be good. Take our C-clamp, put it in these grooves here. Take your ejector pin and slide it underneath there. I like to leave about 1/4 of an inch on the end of the ejector pin before we get to the beginning of the V-block. And then you're going to fasten this down as tight as you can so that during our grinding the ejector pin doesn't wiggle back and forth. So these are our dials that control the various axes that we move on here. This is our Z axis. This moves the entire plate up and down in relation to our wheel. This dial is our Y axis. This controls the plate moving in towards the wheel or out away from the wheel. And then this is our X axis. This controls the side-to-side movement, as you can see here. So as we position our ejector pin about 1 inch to the right of the center point, we're going to move very carefully until we just touch off, and then move the ejector pin off of the surface of the wheel before you turn it on. When grinding your pins, it is important to make your depth of cut, or movement in the y-axis, no more than 3 or 4 thousandths of an inch. Each thousandth is 1 tick mark on the turning dials. Also make sure to move the pin slowly across the grinding surface, going more slowly for larger diameter pins. Okay, so now you've done a couple passes grinding down your ejector pin. Now instead of taking this off to measure it, we're just going to leave it on here, and we're going to get some wide mouth micrometer and open it up far enough to be able to fit it onto either end, and we're going to line it up centered on both ends as close as we can get it to the center. The safety concerns here are similar to those on the chop saw used to rough cut the pins, with a few exceptions. It's ideal to wear gloves since you are now holding the pin instead of clamping it, and the plastic guard shown should be flipped down over the wheel. Rest the pin on the metal rail and slowly press the pin into the grinding wheel to get the desired angle. Since the point is to create an undercut in the pin for the resin to shrink around, it's important to make the cut as close to the shape shown here. This will prevent both the metal and the plastic from being too thin and snapping off during use.